We'd like to welcome you to Math 1108 or 1107. Materials are very similar. What we're going to do is start to do the learn on our Math 1107 and 8 course, in which we have a flipped classroom model in which we have some sort of notebook. You may have received one. And inside, of course, we have the rubric where we'll keep a record of your score on this. The other side, you're going to put the title of the lesson we're doing, and then carefully take the notes of what we'll be showing you. And I'll be reminding you of what we're doing as we do this. And we also want to highlight the titles and the example numbers. So we'll be starting the learn shortly. Now, as we go into the lessons, you may recall from our orientation video, they're in three parts. We have a learn, and that's what this will be. This is our flipped classroom part that you watch before class starts. Take the good notes, and then in class, we have another notebook, which is the practice classwork notebook, which will do some examples. And then following that, you have an open notes quiz on the learn, and then a few new examples. Now, the certify is what you do when you are earning actual points toward your grade in the course. Here, the learn is part of the notebook that is 10% of your grade in the course. Now I've clicked on the Start bar in the Learn, and it brings this page. Now what this page shows us are the objectives that we'll be covering in this lesson. Now you don't have to write these down, but these will be subtopics as we go through the lessons. Now in the first part, we describe this as background. So if you want to title it that, that would be fine. And the title of this lesson, the real number line and absolute value. Now, in life, there are many cases in which we use things from the number line, and we may not be aware. For instance, when we record temperatures, we think of zero sort of being at the bottom of the scale, but there are below zero and above zero. We think of the stock market, that there was no change for that day, or the stock market gained, that would be positive, or there was a loss, that would be negative. We talk about altitude, sea level being zero, and then above sea level being positive values, below sea level negative values. And then often businesses will report break even, profit, that would be positive, or losses would be negative. Now, this is some background. You might or might not have taken notes on this, but here you definitely want to start to take notes. So we're looking at the number line. The study of algebra requires that you know a variety of sets of numbers. So the first set of numbers that we put on the number line are the natural numbers. So what I would write is natural numbers. Now the symbol for the set is the capital letter N, and then you're going to copy this down. Now this is a special kind of notation that we use in mathematics, where we put a brace, and then the number we're first interested in is number 1. That's the first member of the set of natural numbers. And then 2, 3, 4, where we set up a pattern. And then we put three dots to indicate that this pattern's continued. And these three dots, and I want you to write this word down too as part of your vocabulary, is the ellipses. And the way we have put them, this is a certain type of notation. This is called roster notation. And that's something you should have in your notes. Now, the second set of numbers we see listed here, these are called the whole numbers. And we use a capital W to indicate that. And you might say, how are these two sets of numbers different? Well, the whole numbers, we add a 0. Now, we would like you to sketch this in your notes as well. This is a number line where 0 is in the center, and we have some numbers here. Make a small one. This is 1, this is 2, this is 3. I guess we could put a 4 in there. And then we often thicken the arrow head to indicate it's going on in this direction. And if we wanted to graph natural numbers, we would just put a dot on the number line. Now this would be indicative of a graph of the natural numbers. Well, how would I make this into a graph of whole numbers? I would just put a dot on the 0. Now we're going to go on to our next area, but while we have this graph here, I'm going to use it to indicate our next grouping of numbers. Because now, through man's invention, he has actually brought in a kind of a concept of, if you have 0, is there something on this other side? Well, man's invention was that he made up some what are called negative numbers. Now, primitive man didn't know this, but as man started to think and develop mathematics, they developed it. So what would we add to a positive 1 to make it a 0? Well, that would be a negative 1. And to a positive 2 to make it a 0. Well, a negative 2. And we see then, and I'd like you to add this other word to your vocabulary, adding what to a 1 makes it a 0? Well, we said a negative 1. This is the additive inverse. What you can add to a number to make it a 0 is an additive inverse. Now, when we take these whole numbers and their opposites, the additive inverse, we get the next set of numbers, which are called integers. And we'll see that listed below. Now, the symbol we use for that would be a sort of a Z here that has a little thickening, but we could just use a regular Z. And to put that in roster notation, we could use our ellipsis. Let's say a negative 2, negative 1, 0, 1, 2. And you might say, where or what is out there on this end of the number line where these are coming from? Well, we'd like you to add this symbol. This is negative infinity, which is a concept. It just goes on and on and on, never ends. And on this end of the number line, positive infinity. So, again, there are positive integers, there are negative integers, and the unsigned integer is 0. And they're showing you this using roster notation. And the other part, and you can either sketch one like this or maybe not needed, is that we have 0 in the center, and then to the right are positive numbers, and to the left are negative numbers. Now in your notes, you're going to write concept check. And you should write these out. The opposite of an integer is always negative. Now think about that and what we've just mentioned. Is this going to be a true statement or is it false? Can you find one example where it's false? Then it would be false. Well, if the number itself is negative, then its opposite is going to be positive. So this would be false. How about number 2? The opposite of a 0 is undefined. Well, the opposite of 0 is 0. Now, being undefined is something we will go over a little later. All right, let's continue. Now, this is something important to include in your notes throughout all of our lessons, and that is the example number. So you're going to put here example 1. All right, state the opposite of 7. Well, the opposite of 7 is negative 7. State the opposite of a positive, or I should say, a negative 4. Well, that would be a positive 4. Now, notice that they're giving you another way to show that. If you were to convert this statement to writing, the opposite we can think of sometimes as the negative sign. The opposite of a negative 4, that is, the opposite of a negative is going to be a positive. And generally, we don't write the positive in front of a number if it is positive. All right, let's go on. Again, in your notes, you're going to write example 2. So part A, graph on a number line these values. So you make a sketch of a number line, and then negative 3 is there, negative 1 is there, 1 is there, and 3 is there. That would be for A, and then put these there as well. B, another number line, and write these examples in your notes. Negative 4, negative 2, negative 1, and 2. Now, this is setting you up for our classwork, which comes later, and then the certify, which will ask you to do problems like this. And you'll, of course, need to know the technique of putting that into the computer. Now, as we continue our study of the number line, we want to create a number line, and I'm going to give you some background here. So let's make a nice line, actually. I'll take that one away and make a nice line here. So in your notes, you're going to make a nice line. And on that line, you're going to put a 0, you're going to put a 1, and you're going to put a 2. That should be enough for our values here. And so far, well, we ought to put a negative 1 there too. Now, these would be integers. Remember, this 1 and 2, natural numbers, 0, 1, and 2, whole numbers. When we include their opposites, these are integers. But are there other numbers on the number line? And the answer is yes. For instance, right here, there is 1/2, which we think of as a fraction. Now, when we take 1/2, and take some notes on this, and convert this to its decimal form, we get 0.5, and it terminates. Another number, right about there, is 1/3. And if we convert 1/3 to its decimal form, it's 0.3, and it continues, 3, 3, 3, 3. To indicate that it continues, we put a repeating bar over the 3. That's the part that repeats. And this doesn't terminate, but it repeats. Now, along with the natural numbers, the whole numbers, the integers, we've now introduced numbers between that, and these, along with these other numbers, are called rational numbers. This is the set of rational numbers. Now, what are the rational numbers? Well, they are the natural numbers, the whole numbers, the integers, and then fractions in their decimal form that terminate or in their decimal form repeat. These are all rational numbers. And the symbol for rational numbers, and I'll go back to my thicker pen here, is the letter Q. Now you might say, how come they chose a Q? Well, just not to get it confused with the next type of number, because there are other numbers on the number line too, which are called irrational. And write that down. Now, what are irrational numbers? Well, by definition, in their form, in their fractional decimal form, they do not repeat, as we see here, or terminate, but just go on forever. And what would be examples of these? Well, I'll go to my thin pen again. And just about here, a little less than half, we have what is called the square root of 2. Now this is a radical. Radicals generally are irrational. And you might say, how come not always? Well, if we have the radical form of 4, which is the square root of 4, this simplifies to 2, which we see here is a natural number, a whole number, an integer. So even though it has that radical sign, which is the square root of something, we see it then becomes one of these others. So this would not be irrational, even though it had the radical sign. But values that are under the radical sign, that are not perfect squares, they are all irrational numbers. And examples of some irrational numbers would be the square root of 2, of course, the square root of 3, not the square root of 4, but then the square root of 5, the square root of 6. Another famous one is pi. And then one is the letter E. We call that Euler's E that we'll be using later in the course. All examples of irrational numbers. Now, is there any other names of sets of numbers on the number line? And the answer is yes. And I'll write it here so you could have it concisely in your notes, and that would be real numbers. All of the numbers on the number line are real numbers. And the symbol we use for that is kind of a thickened R here. And that's why we don't, for rational, we don't use the R, we use the Q. All right, hopefully you're getting some good notes here. Here are a few more examples. You can or cannot take these down, it's not needed. So there would be a terminating decimal, repeating decimal, and here's another form of repeating decimal. These would all be rational numbers. And then examples of irrational numbers, the square root of 2. Notice there is no repeating pattern. No repeating pattern. And let's go on. Now you don't need to copy this into your notes, although if you want to, you can pause, of course, and that's the nature of these. You can always pause. You can actually speed it up if needed. You can return, go to earlier sections, or play the whole thing again at a faster speed to review. But here are all the numbers on the number line. So we see the real numbers are, irrational numbers, rational numbers, Q, I for irrational, and then we have the integers. Here we have negative integers, whole numbers, which make up the integers, and then we have natural numbers, and then the zero added to natural numbers to make up the whole numbers. Notice the initials. You should be familiar with that. All right, let's go on. Now, for example 3, remember you're writing these down. List the numbers in these sets. So here's the set. Which are the whole numbers? Which are the integers? Which are the rational numbers? Which are the real numbers? Well, for real numbers, you're going to list all of them. Now, for the whole numbers, you're going to list a 0 and a 17. For integers, you're going to list the -5, the 0, and the 17. For the rational numbers, you're going to list everything but the square root of 2. And for the irrational numbers, the only one that would be is the square root of 2. Now, for real numbers, again, it's all of these numbers. Again, pause, take some notes. Now, for example 4, again, you're going to write that down. Graph on a number line. So, again, you're going to sketch this and then carefully put your points in so you get an idea of what these are like. And again, pause. Now for example 5, again, you're writing this down, example 5, going to draw a number line. They're asking you to graph all natural numbers less than or equal to 3. Well, since it's equal to 3, we put a dot on 3, then 2, then 1. Now, do you put a dot on 0? And the answer is no, because this is a natural number. But if they had put here whole numbers, just giving you a little more background, then you would have put a dot on the 0. That would have been the graph. And you'll have things to do like this again in the practice and certify. All right, this is for background and vocabulary. They're asking us, and write this in here, inequality symbols. Well, one of the first is one that looks like so, which is read is less than. Now, we could also put a bar underneath this. This now becomes less than or equal to. Another one you're going to have is this, which is the greater than, and then a bar underneath greater than or equal to. So here are some values of this, and we can scroll down a little bit here. Where are things on a number line? Well, again, if something is less than, it's going to be to the left of something on the number line. Greater than to the right. And one other little thing about this for your notes is that if you have an inequality symbol that looks like this, less than or equal to, greater than or equal to, if part of what they're saying is true, then this is true. All right, let's go on. Here is a summary, and I think you are familiar with these other symbols here. Equal to, and then the equal with a slash through it, not equal to. All right, now in these, and this is example 6A, going to write this down. Is this statement true or false? 7 is less than 15. That's true. 3 is greater than -1. That's true. Now, negative 1/2 is less than or equal to a negative 1/4? Well, for things like this, if you're not sure, sometimes the number line helps. There's 0. There's a negative 1. Now, a negative 1/2 would be sort of in the middle. I didn't do that very well. But a negative 1/4 is about there. So is negative 1/4 to the right of a negative 1/2? And the answer is yes. So anything to the left is going to be less. So this is true also. Now here we have like a conundrum because it says 2.7 is greater than or equal to 2.7. Now we know it's not greater, but does it equal? Part of it is true, so this is true. Now negative 5 is greater than negative 6. Again, a number line would help. There's negative 5. There's negative 6. Negative 6 is to the left, so therefore negative 5 is greater. These are all true. Now our last topic here is absolute value. You want to write that down. Now what is absolute value? Well, it refers to the number line and the distance something is from 0. Now if we look at a positive 7, how far in counting numbers is that from 0? Well, it's 7 units. Well, how about a negative 7? How far is that from 0? Again, that's 7 units. So we say the absolute value is the distance something is from 0, so it's always going to be positive because this is a measure of distance. Now we write absolute value of 7 by putting 2 vertical bars on either side. Absolute value of negative 7 the same way. So the absolute value of 7 is 7. And the absolute value of negative 7 is also 7. That in general, the absolute value of anything is its positive value. The one exception is the absolute value of 0, which is unsigned. All right, have some good notes on this. All right, for these are pretty straightforward. Example 7, don't forget to include the example number. Absolute value of 6.3 is 6.3. The absolute value of negative 5 is a 5. Now here's a little tricky. We have a negative sign in front and we have a negative 2.9 for example C. And the absolute value of a negative 2.9 is 2.9. But then we have to apply this negative sign. Or we can think of a negative 1 being there, and then negative 1 times 2.9 makes this a negative. So whenever there's a negative sign out in front of the absolute value, it ends up as being a negative. Now for example 8, write this down. True or false? The absolute value of negative 4 is greater than or equal to 4. Well, you take it out of the absolute sign and it becomes a positive 4. 4 is greater than 4? No. But is 4 equal to 4? Yes. So then this is true. Okay. Just 2 more examples to go. Example 9. And it says the absolute value of x equals 7. What could x have been? Well, it could have been a negative 7 or a positive 7, keeping that in mind, and that would be that one. And let's just go on to the next one here, which is our last example. Now, can something like this be true as we look at example 10? The absolute value of x is equal to a -3. Now, what did we say was the definition of absolute value? It's always going to be a positive. So this has no solution because this is not possible. All right, this winds it up. It ran a little bit long, but hopefully lots of background and you've got a good handle on what we're looking for in your class notes. Highlight the titles, highlight the examples, and keep in mind we can use these examples on our quizzes.